Let's look at section 5.6, negative exponents and scientific notation. First, let's look at a few definitions. Let's look at the definition of scientific notation. This is a number written, whenever a number is written in scientific notation, it has the form a times 10 to the n, where a is a real number, such that the absolute value of a is bigger than or equal to 1 and less than 10. And n is an integer. So one of the things that we need to be reminded of is the negative power rule. To remove a negative exponent, switch the position or location of the base, and by that we mean if the base is in the numerator, move it to the denominator. If the base is in the denominator, move it to the numerator, and change the exponent to a positive. So this is what you do when an exponent is negative. So you change the sign of the exponent as well as change the location of the base. So here's an example of that. A to the negative n is the same as 1 over a to the n. So the a moves to the denominator, the n changes sign. 1 over a to the negative n is the same as a to the n. A moves to the numerator here, and the exponent changes sign. And of course, a would have to be different from 0. All right, so let's simplify. Let's use this negative power rule to simplify 10x to the negative fifth. Well, this power of negative 5 only applies to the x. So 10 remains in the numerator, but x goes to the denominator, and the sign of the exponent becomes positive. So this is the same as 10 over x to the fifth. If I want to simplify y to the negative eighth over x to the negative fifth, I am going to need to change the position of both bases. My x is going to come in the numerator. The power on x, therefore, is going to change from a negative to a positive 5. Y is going to go in the denominator, and the power on y changes from a negative to a positive 8. So that would be how I would simplify that. When I simplify exponential expressions, there are 4 requirements that need to be true for the expression to be simplified. No parentheses or grouping symbols are present. No zero or negative exponents are present. No powers are raised to powers. Each base only occurs once. So let's simplify this expression that we find in number 5. We have a power of negative 2 applied to 3x squared y cubed. So, and that's in the numerator. So we're going to move 3x squared y cubed to the denominator, and the exponent of negative 2 changes to its opposite, positive 2. In the denominator, xy is raised to the negative 25. We're going to move that to xy to the numerator and change the negative 25 to a positive 25. All right, now we're going to use the product to power rule of exponents. xy to the 25 is x to the 25, y to the 25. 3x squared y cubed squared is 3 squared times x squared squared times y cubed squared. So I have x to the 25, y to the 25 over 9, x to the 4th, y to the 6th. So when a power is raised to a power, these exponents are multiplied. 2 times 2 is 4, 3 times 2 is 6. So this becomes x to the 25 minus 4, using the quotient rule of exponents, y to the 25 minus 6, all over 9. The 9 stays in the denominator. So this equals x to the 21 times y to the 19th all over 6. So that would be my final answer for that one. So let's look at scientific notation. We want to convert from standard form to scientific notation. Write the real number factor A by moving the decimal point so that the absolute value of A is greater than or equal to 1, but less than 10. To do this, place the decimal point to the right of the first non-zero digit. All right, so here we have a number that we want to write in scientific notation. Let's apply step 1. So we notice that the first non-zero digit here is 3. So I'm going to place the decimal to the right of 3, and then I copy 0, 5, 2. I don't need to copy the rest of the numbers because they are all zeros. But I do have to copy these numbers that come before the ending part that's all zeros. And I'm going to multiply this by 10 to a power appropriate for the situation. So notice I've actually moved the decimal 1, 2, 3, 4 times 3. So that's 3, 6, 9, 12, 13, 14 places. So if I multiply 3.052 times 10 to the 14th, I will get the number back in expanded form. Now notice, look at step 2 above to see that I'm going to, step 2 is kind of outlining what we just did when we had to deal with the power of 10. So I'm going to be multiplying the number by 10 to the nth, the number A by 10 to the nth, where the absolute value n is the number of places that the decimal point moves. If the decimal moves to the left, then n is greater than 0. That means n is positive. If the decimal point moves to the right, then n is less than 0, or another way to say that is n is negative. Removing these zeros lying to the right of the last non-zero digit or to the left of the first non-zero digit. So we've actually done both of those things for problem 6. We moved 14 places to the left, so the power on 14 was positive. All right, let's write this number in scientific notation. So 7.8 89 would be my A. So here I'm moving my decimal to the right until it's to the right of the first non-zero digit. And that gets multiplied times 10 to the, and I moved 1, 2, 3, 4, 5, 6, 7 decimal places to the right. So this has to be a -7. So the other thing I'll need to do is to convert from scientific notation to standard form. So I'm going to remove the exponential factor 10 to the nth. I'm going to move the decimal point absolute value of n places, inserting 0 placeholders as needed. If n is bigger than 0, or another way to say that, if n is positive, then I'm going to move the decimal point to the right. If n is negative, I'm going to move the decimal point to the left. So an example is 4.98 times 10 to the -5th. We want to write that in standard form. The exponent is -5, so we move the decimal point 5 places to the left, filling in 0 placeholders as needed. And we see our result. All right, let's write 5.3789 times 10 to the -9th in standard form. All right, so I'm going to write the digits with no decimal point, 53789. And I see that the power on 10 is -9. So I'm going to need to move the decimal from between the 5 and the 3, 9 places left. So to move to the very left of 5 is 1 decimal place. And I need to move 9 to the left. So I'm going to add 8 zeros. So again, I copy the digits, and when I move from the decimal point from between 5 and 3, I've moved 1 place to the left. I've got to add 8 zeros to move a total of 9 places to the left. Okay, so this is what this number would look like in standard form. Let's write 2.25 times 10 to the 6th in standard form. So 225, we've already moved the decimal 2 places to the right, but we need to move it a total of 6, so we need to add 4 zeros. Starting from the right, if I were to move 1, 2, 3, 4, 5, 6 places left, then that would be the equivalent of what I started with. So this is, and I can put in commas, this is 2,250,000. Okay, so one of the things that happens is sometimes I need to multiply and divide with numbers in scientific notation, and I want to make sure my final answer is in scientific notation. So if I multiply 1.8 times 10 to the 5th times 3 times 10 to the 8th, I multiply the 1.8 times the 3 and get 5.4, and 10 to the 5th times 10 to the 8th is 10 to the 5 plus 8, which is 10 to the 13th. So notice that this is simplified and it's in scientific notation. Now let's divide 2.16 times 10 to the 12th by 4.5 times 10 to the 3rd. I'm going to regroup the factors. I'm going to put the numbers together and the powers of 10 together. And then I'm going to work accordingly. So 2.16 divided by 4.5 is 0.48. 10 to the 12th divided by 10 to the 3rd is 10 to the 12 minus 3, which is 10 to the 9th. So I've applied the quotient rule of exponents. Now I need to write 0.48 in scientific notation. That's 4.8 times 10 to the negative 1. So I'm going to regroup this so that the 10 to the negative 1 times 10 to the 9th are combined. So I get 4.8. So 10 to the negative 1 times 10 to the 9th is 10 to the negative 1 plus 9, or 10 to the 8th. So here's my final answer. So let's look at exercise 10, where I'm going to multiply 5.3 times 9.4, and that's going to get multiplied by 10 to the negative 9th times 10 to the 39th. All right, so we will calculate on our calculator 5.3 times 9.4. And we get 45.82. Oh, I'm sorry, 49.82. Sorry about that. 49.82. And then when we multiply 10 to the negative 9 times 10 to the 30th, the power that goes on 10 is negative 9 plus 30, which is plus 39, which is 30. Now we want the answer to be in scientific notation. This isn't, because 49.82 cannot be our A. But what we're going to do is we're going to rewrite this as 4.982 times 10. So I move the decimal to the left, so this exponent on the variable is going to be positive. It's an unwritten positive 1. And this gets multiplied by 10 to the 30th. And 10 times 10 to the 30th is 4.982. It's multiplied by 10 and 10 to the 30th. Well, remember 10 is really 10 to an unwritten power of 1. So 10 times 10 to the 30th is 10 to the 31st. Okay, let's look at dividing. We're going to take the A values and divide them. So in this case, that'll be 1.3 divided by 9.58. And that gets multiplied by the division of the powers of 10. So 10 to the 18th divided by 10 to the negative 52. When we use our calculator and divide 1.3 by 9.58, we get 0.13569 And then when we use the quotient rule of exponents on the powers of 10, we get 10 to the 18th minus negative 52. So that double negative becomes a positive, addition of a positive. We need to write the 0.135699 in scientific notation. So we get 1.35699. We move the decimal one place to the right, so this will be times 10 to the negative 1. And then if we simplify this exponent from our division of the power of 10s, we get 10 to the 70th. So 10 to the negative 1 times 10 to the 70th is 10 to the 69th. And we recopy the A, 1.35699. And that's our final answer.